Colleagues and organizers, thank you for the opportunity given at this event. Special thanks and congratulations on the anniversary and to Anatoly Korkin, the ideological inspirer of the conference. Allow me to present my work on the topic of antibiotic resistance and human and veterinary medicine, problem and solutions. The problem of antimicrobial resistance is a global problem of the 21st century. According to the World Health Organization, in agriculture and aquaculture used more than twice more antibiotics than in medicine. The massive administration of antimicrobial drugs in agriculture causes the development of antibiotic resistance of microorganisms which, when ingested, transmit resistance genes to the microbial community of the human body. Therefore, the appointment of antibiotic is ineffective. Disease caused by antibiotic-resistant microorganisms are characterized by a more severe and prolonged course, which causes significant damage to the state and each individual family. Antibiotics of the fluoroquinolone group can cause arthropathy in children under 18 years of age, as well as the appearance of increased cellular activity in the elderly. Most of antibiotics are excreted from the body of animals and poultry with fetus practically engaged. As part of organic fertilizers, they are taken out to the fields while they are not destroyed within 1 to 2 years, even when frozen and heat treated. Antibiotics affect the soil microflora, causing its death and the emergence of resistance. Since antibiotics do not act on viruses and fungi, plants develop viral and fungal lesions, which reduce the yield and quality of the resulting crop production. All parts of plants absorb antibiotics, which, as parts of plants' products, enter food for humans and animal feeds, causing various damage to the body and aggravating the problem of antibiotic resistance. Closing the circle of circulation of antimicrobial drugs in nature is where ingress from soil into water, which also does not contribute to solving the problem of antibiotic resistance. The problem is most clearly manifested in the context of scalna production. This problem is typical for Russia, and China faced it then due to the loss of more than 70% to the pig population. It began to develop industrial poultry farms. With the maintenance of a large number of livestock per unit area, the possibility of passage and enhancement of the virulence of microorganisms, primarily of bacterial etiology, is greatly enhanced. Virulent microorganisms cause a decrease of the resistance of the organism of animals and birds and the occurrence of diseases. It is impossible to abandon the administration of antibiotics in either human or veterinary medicine. However, the mechanism of resistance is more than 3 billion years old, so the invention in the antibiotics will not be able to help humanity in the solving the problem of antimicrobial resistance. Only a scientifically grounded approach to studying the mechanisms of the emergence, spread and extinction of antimicrobial resistance, improvement of methods for detection sensitivity and prompt response to the emergence of resistance during treatment can help in the spread and prevention of antimicrobial resistance and human and veterinary medicine. Our scientific consulting Center was created to unite scientists in order to develop and implement multitasking projects in the field of veterinary medicine and agriculture. Unfortunately, the existing scientific infrastructure does not allow for a large volume of multifaceted research on living biological models, but the results we receive inspire further innovations. In the summer of this year, we conducted studies to study the development of resistance of gram-positive and gram-negative microorganisms to fluoroquinolones. Fluoroquinolones are the most common group of antimicrobials used in the poultry industry. In humans, it is used to treat of urinary tract, sexually transmitted, intestinal, respiratory, surgical, and gynecological infections. They are affected in septicemia, in bacteremia. The development of resistance of microorganisms to fluorohormones is carried out by the implementation of several mechanisms: modification of the target of action and active elimination. We have conducted study to development of resistance of Escherichia coli and Staphylococcus aureus of 100 chickens from 1st to 28 days old. From 1st to 11th day of life, the chickens were kept in brooders. From 11th day, they were transferred into boxes. From the 2nd to the 6th day of life, they received the antibacterial drug of fluoroquinolone, an active ingredient, and rofloxacin. On the 1st, 4th, 8th, and 7th day of life, samples of litter were taken for bacteriological resistance. Determination of the sensitivity of microorganisms to microbial drugs were carried out by the disk diffusion method. Already before the use of antifloxacin, the isolated microflora had a high sensitivity to all antibiotics of fluorone group: ciprofloxacin, enrofloxacin, and levofloxacin. Already on the 4th day of enrofloxacin application, the sensitivity of Escherichia coli to the indicated antimicrobial product becomes 0. After 5 days of administration of enrofloxacin, resistance of Escherichia coli to all of the listed fluorohormones except for ciprofloxacin was established. Subsequently, the sensitivity of Escherichia coli to ciprofloxacin and enrofloxacin continued to decrease, while the sensitivity to levofloxacin as a new generation fluorohormone began to recover. On the 11th day after the end of taking enrofloxacin, it reached the value intermediate resistance. The results of studying the sensitivity of staphylococci correlate with the results obtained for Escherichia coli. From the results of our research, it follows that it is necessary to control the sensitivity of microorganism circulation at enterprises and the administration of antimicrobials based on the results of the relieved sensitivity. Otherwise, the use of antimicrobials will be ineffective. The second most important issue is solving the problem the antimicrobial resistance is industrial livestock and poultry farming in the aftermath of dasoprotection and prediction the effectiveness of therapy. At present, the results of bacteriological research, even in the most advanced farm, are processed in Excel format. Algorithm for prescribing antibiotics includes 3 steps. Step 1: sampling of biomaterial and identification of pathogens. Step 2 include determination of sensitivity to antimicrobials and accounting of results. Step 3 includes selection and appointment of antimicrobial products and analyzing of the effectiveness of application. But it is very difficult and hard work, so we have developed a prototype of a software package for an automated decision support system for monitoring, retrospective diagnostics, and predicting the sensitivity of microorganisms to antimicrobial drugs for veterinary administration. We named it MicroSense. MicroSense provides the automation of the processing of research results and the appointment on effective antimicrobial drugs, taking into account the characteristics of the production cycle of a particular enterprise. Targeted determination of sensitivity to antimicrobial drugs, taking into account the production technology and the epizootic situation on the enterprise and at the region. MicroSense provides a risk-based approach to antibiotic administration, aimed at preventing and limiting the spread of antimicrobial resistance in industrial livestock and poultry production. Development of scientifically based methods and algorithms for predicting the effectiveness of decision-making of the administration of antibiotics in various branches at animal husbandry at all stages of a production cycle. Another innovation required to solve the problem of antibiotic resistance in human and veterinary medicine is the reduction of the duration of studies to determine the sensitivity of microorganisms to antimicrobial drugs and the prescription of effective antibiotics. Today, the minimum study period is 2-3 days. There are some number of studies have been carried out to study the expression of resistance genes, but most of them are of an unsystematic selective nature. In our opinion, the ideal solution is PCR or the development of biochip technologies. So now we are working under this program. In practical terms, we have developed a scientifically based system for the control of infectious disease, the administration of antimicrobials, and the production of safe livestock products in the context of scaled-up production. The technology ensures the production of high-grade, safe, high-quality food products without increasing the cost of production. It was developed at the largest enterprises of the Russian Federation under the guidance of veterinarians, candidates of veterinary sciences. The implementation of technology at enterprises takes 1.5 and 2 years. We hope that the development of innovations will provide a shorter time frame and an early solutions to the problem of antimicrobial resistance. Let's save antibiotics for future generations. Thank you for your attention.